This is the Tinmith Evo 5 user interface demonstration video covering outdoor construction examples. Street furniture placement with table. In this example, we are using the Tinmith modelling system to place down a table to match against a table in the real world. As you can see, the user has placed a table down approximately near the location of the real table. The virtual table floats in the air and appears in the correct location using the orientation and position sensors on the backpack. We can then move the table into the correct position using the gloves and the moving gesture. By clicking the buttons, we can tell the system that we want to move objects around. We can also perform rotation operations on the table using hand gestures, and we can also perform scaling operations using the hands. It should be noted that we use two hands in some cases, as doing these gestures is more intuitive than using just a single hand would be. As you can see now, the table is in the correct location, and so we can now move on to modelling further objects outdoors. Carving of complex automobile. In this example, we have pre-placed down a black box at the same location as a car. What we are doing here is clicking points onto the surface of the box, indicating where we would like to perform carving operations. The box is then carved up according to where the points are placed, and we click the glove each time to indicate the corners are of interest to us. By clicking the glove, we build a complete shape around the surface of the car. The final point is now in place, and now we solidify the object, producing a carved box which approximates the shape of the car. From the external virtual reality view, we can see the shape of the car as we have carved it. Building with sloped roof. In this demonstration video, we are using the infinite planes technique to mark in the geometry of a building. In this technique, we sight down each individual wall and press a button on the glove. A plane is then fired from the direction we are looking into the building, and by walking around and looking down each face of the building individually, as can be shown in this video, we can mark in the individual walls to produce a solid shape. 4 walls have been marked, and now given this, we now have a shape that matches the perimeter of the building, although the roof is still infinite. If we go to the external virtual reality view, we can see that the building shape has been defined and is registered correctly. Now we are going to carve in the sloped roof. Using the same techniques as demonstrated earlier with the automobile, we can click points on the roof to match against the object. Now we define the rest of the perimeter to make sure the object is fully consistent. And now if we look at the building registers, and you'll also notice that it has a carved roof. Note that the inaccuracies are due to jitter caused by the tracker and other problems associated with augmented reality tracking technology, which is not perfect yet. The virtual reality view shows what the building looks like in a virtual world so that we can get a better idea as to what it looks like. Breadcrumb perimeter creation. In this technique, we use what's called the breadcrumbs, which is based on Hansel and Gretel's story about how they found their way home using breadcrumbs dropped on the ground. The user walks along the ground, defining out a grassy patch. By pressing a button on the glove, small marker cones are placed down where their feet are. By walking around the perimeter of the object, they can then mark in each of the markers and then create a solid outline. In this example here, we can see the user is slowly placing down markers, defining the grassy patch that we showed earlier in the video. The user then turns around and walks back to complete a solid outline of what the object they're interested in modelling. We use the virtual reality view in this demonstration as it best conveys what we're trying to do. So there is the completed perimeter, and this is what the perimeter looks like when it's viewed through the head-mounted display by looking at the grass. As we can see, the grass is aligned with the green polygons that we've created earlier. Surface of revolution tree creation. Using the surface of revolution technique, we can use this to create the shapes of trees which would otherwise be too hard to model. Currently, the user is moving their hands around to select the colour of the tree that they would like to create. Now they walk up to the tree and create a backplane which will be used to draw on. This backplane is used to record the points that we'll be drawing and then to revolve the surface. The user clicks on this invisible plane and creates points which will be used to define the surface of the tree. We click on only the left side of the tree and mark in points which define its silhouette if it were cast against a wall with a bright light. As you can see here, we have marked in the interesting points, and now what we do is define the rotation axis. Once the rotation axis is defined like now, we can see that the system has revolved the object to create a spherical tree-shaped object. If we look at the object in the virtual reality view, you can see that the object is green according to the colour that we selected earlier, and we can see that the object is round. Chemical box with captured textures. In this example, we place down a black cube which approximates the position of a real cube in the real world. We then manipulate this cube into place to match up against what we can see in the real world using move and nudge techniques. Once the object is in position, we can now capture video textures by using the video camera which is mounted on the head-mounted display. We select capture mode and now take the photo, and the system maps the texture against the real object. We do the same from different angles, capturing the texture of the left wall, and now capturing the roof of the box, and now from the other side we complete the texture map by capturing this one as well. In that case, you can see that the glove was in the way, so the photo had to be reshot with the glove out of the way to ensure that the texture was captured accurately. And from the virtual reality view, we can see that the box has been modelled with 3 textures. Artificial abstract building creation. In this example, we use the Tinmith modelling system to prepare a large object which has been elevated into the air using the manipulation techniques and then carved using the special carving techniques. It should be noted that the building has been carved into 2 separate components in order to make it more complex. This allows us to visualize what an object will look like without actually having to build it in advance. This has been a Tinmith demonstration video. For more information, please visit our website. Thank you.